Hello, my friends. Imagine walking in the dark and suddenly spotting a rock glowing with green, blue, or even red light. No, this isn't a myth or an optical illusion, but a fascinating scientific phenomenon known as glowing rocks, specifically due to fluorescence and phosphorescence. When certain minerals within rocks are exposed to ultraviolet UV light, they absorb its energy, but they don't keep it. Instead, they re-emit it as visible light. This is called fluorescence. However, this glow doesn't last. It disappears the moment the UV light source is turned off. That's because the electrons that absorb the energy quickly return to their original state, releasing the light in a flash. Phosphorescence, on the other hand, tells a different story, of electrons that refuse to return quickly. When they absorb energy, they jump to high energy states, but get stuck there momentarily in an unstable excited state. Because their return to the ground state takes longer, due to the mineral's complex atomic structure and quantum constraints, they release the energy gradually, glowing even after the light source is gone. That's why some rocks seem to glow in the dark on their own. But what determines whether a rock will fluoresce or phosphoresce? The answer lies in several factors: the type of mineral, the nature of the activating impurities inside it, the crystal structure, and even temperature. Some minerals react instantly and emit light right away, fluorescence, while others store the energy and release it slowly, phosphorescence. The light in these rocks comes from tiny impurities called activator impurities within the mineral's crystal structure. These impurities excite electrons, pushing them to higher energy levels, and the light is emitted as they return. The colors we see vary based on the type of impurity, chemical composition, the amount of absorbed energy, and the specific mineral in the rock. For example, fluorite often glows blue or green, willemite glows bright green, calcite can glow in many colors depending on its impurities like red, orange, or yellow. To observe phosphorescence specifically, the conditions need to be just right: complete darkness free from light pollution, low temperatures to help electrons retain energy longer, a sufficient amount of activator impurities, and prior exposure of the rocks to strong sunlight or UV light to excite as many electrons as possible. Some large or well-structured minerals may continue glowing faintly even after sunset, but we only see it when the darkness is truly deep. Witnessing this magical sight takes nothing more than a dark room and a small UV flashlight. As soon as you shine the light on the samples, they erupt into a breathtaking light show. The phenomenon of glowing rocks is a magical reminder that nature's beauty doesn't always appear under ordinary light. Sometimes we just need a different angle and a hidden spectrum to see what's been there all along. If this discovery amazed you, don't forget to hit the like button and subscribe. Nature still holds many more secrets. Goodbye, see you in the next video.